then this lost is not detected by the client with some timeout. It's usually it's in old and current VARS protocol detected with receiving packet with ID 33 because it accepts ID 32. This mechanism is much more efficient than timeouts in this case. And how would client solve this packet lost? If TCP would be used at transport protocol, then position of the second frame would be retransmitted, which is useless in this case because this position is not useful anymore. What is new in VARS 2 protocol is that this acknowledgement about receiving some packet or not receiving packets is piggybacked to all following acknowledgement packets. Of course, this acknowledgement has to be somehow limited. It is limited with acknowledgement of acknowledgement. I will describe it at following slide. Yeah. So in this case, there is sent payload packet with some information, for example, position of object, and the server acknowledgement receiving of this packet with some acknowledgement packet. And this information is piggybacked to some payload packet sent from server to the client. And here is example of acknowledgement. In this packet, it is acknowledgement packet is sent acknowledgement of acknowledgement. It means that server now needing to send this acknowledgement anymore because in this packet client inform server that it received this acknowledgement. Oops. This is case where packet is lost. This packet lost is detected by the server when this new packet with ID 33 is received because it expected 32. Yeah. This is structure of new of packet of new VARS protocol. There is version at the beginning, so you can deal with several versions of VARS protocol. There are some flags. They are usually used during handshake. There is payload ID. It is increasing when every new payload packet is sent. This ID is used when this packet includes some ECK or NEC commands acknowledging receiving some payload packet. And this is ID that is acknowledgement of last acknowledged payload packet. After ECK and NEC commands are some system commands, and these commands are not usually used. It is used usually during handshake for some negotiation and so on. And there are some node commands that are used for transmission of data. This is a structure of packet of old verse protocol, so you can see that old verse protocol was very minimalistic. How are data compressed? I will try to explain it at this slide. When we send only one vertex set command, it's simple. But when we use this command in all verse protocol, there are many duplicities. Because all these IDs are the same. But when we use new verse protocol, then every command has second byte used for length of the command. So we can add more data in one command, and this saves a lot of space in this case. Of course, our NEC and ECK commands use some compression too. When DTLS is used for encryption, then deflate compression is used. So when you use security of DTLS, then it is compressed too, and it is efficient. What about data model? New verse protocol use nodes as old verse protocol, but all nodes as same time same type. What is also new is access permission. You can set if other users can subscribe or not subscribe to some node, if they can send data to nodes, and you can also use logs. It is very important for user perspective. Let's consider this case when you are editing this cube, and some other user want to move this one with this cube. Then this cube would be moved from the view of this user, and it would be very very confusing to the user editing this cube. Yeah. This is the case when logs could be used. The other case when this is useful is for integration of VARS protocol to some existing application like Blender, because I found the implementation of VARS protocol to Blender very hard, because I had to solve many cases. For example, when you send some data to VARS, then these data are resent to you. But these data can come from some other application. So there is really hard to distinguish between data coming from some other application and data coming from VARS as acknowledgement of data you sent to the VARS server. So there are same things with old VARS server. For example, subscribers, tags, links. Links are not something optional. It has to be used because I use some tree structure for nodes. It has many benefits, and it could lead to some simpler implementation of some things. And all data will be stored in arrays. There is some slide about access permissions, but I think it's not too important now. I would like rather to speak about special nodes. As I said, the new VARS use tree structure. There is base node, and there are 3 other special nodes connected to this base node. It is a node that is parent of avatar nodes. Avatar nodes are created by the server when you are connected to the VARS server. These nodes are created automatically and are automatically destroyed when you are disconnected. This second node is used as a parent of user nodes. So when you are connected to the VARS server, you can see what users what users have account there. And the third special node is parent node of scenes. These avatar nodes are used for creating of new objects. When you create new object, then this object is connected to this node, and you can then relink it to the scene node, some of the scene node. So what about implementation? VARS server has many threads. There is one TCP thread that listens for new connection, and when a client is connected, attempt to connect to the VARS server, then one TCP thread is connected. When this client negotiate UDP connection, then there is created UDP thread for this UDP connection. And of course, there is one special node, I call it data thread, which store all data and do synchronization between all UDP connection threads. So it is many multi-threaded application, but it is not something special. Many servers use this approach. It is used mostly because the problem with UDP socket. If we would use only one UDP socket, then not reading enough fast from UDP socket would lead to unnecessary packet lost. Whereas client uses a similar approach. It means when there is main thread, data thread, and you call some function that connect this client to the VARS server, then a TCP thread is created. It is again used for negotiation, authentication, and when it is finished, then UDP thread for connection is created. The excuse me. Communication between main data thread and connection UDP thread is used with queue. Same queue is used for communication between UDP connection thread and data thread at VAR server. This is some visualization of the queue. When you want to add some new comment to the queue, for example this, then this comment is not added to the tile of the queue. It is usually added, not usually, but it could be added to the, for example, in the middle of the queue. How is it done? Every message has some comment. Yeah, this could be, for example, position of object, or it's some stupid example. But when the same address is found, then this comment replace this comment. Why is it useful? Let's consider the situation when there is congestion and you can't send so many data as you want. So sending of this position is postponed, and adding this new command on the end would not improve the situation. It would make situation even worse, because position of this object would be sent twice, and this position would be obsolete.
Can you wrap up in 5 minutes?
Yeah.
Then we also have some little time for discussion.
Mm-hmm. Okay. So some technology about implementation. It is written in C language. It uses sockets. It uses some external libraries. It uses vthreads and OpenSSL, and it uses LDAP library, but it's linked with it, but it's not used now. I use Doxygen widely for documentation, and the library as is now is about 75 kilobytes size. It's not much, but when it is linked with static library from OpenSSL, the size is growing very much. What's the new in implementation in API? Each callback function has one function for registration. Also, old verse protocol used one function for registration, and you could do many silly bugs when you called this function. So this approach helps to avoid to the bugs. The function, for example, that connect you to verse server is different too. There is host name, port number. You can add, there are some flags saying that you want to use encryption at UDP connection or not, for example. And when you register it before some necessary callback function, then this function return some valid session ID. The authentication is done in some special callback function. It is different from the old verse API. The verse callback update is used to it should be used one per frame because it leads to calling callback function. Yeah. This function should be used from this main data thread. Yeah. When you call this function, it leads to synchronization from connection UDP thread to the main data thread. This approach is good because when you are doing here some rendering, for example, for a long time, then you are not disconnected from the verse server because this UDP connection thread do the communication between verse server. And there's also many verse and function sending data to verse server, and you can you can call this function as many times as you want because this queue approach will lead to efficient sending of data. I would like to thank to Minister of Education of Czech Republic, which supported this research, and that's all. Thank for your attention.
You don't have test results like to compare speed or?
I did some tests. I created some special application for testing many transport protocols and verse. I will show you some video.
Okay. Yeah. We have 5 minutes discussion, that's it, and then we have to move on.
there is used pure UDP protocol, and you can see that when there is some congestion, when there is big traffic, then then some packets were lost, but some position of bouncing particles were not recent, so it leads to inconsistency of data at server and client. Yeah? In the second case, there is TCP protocol used. In this case, all data are recent, but you can see that there is there are high delays. These delays are visualized with these lines. It is expected position and it is received position. So you can see that delay is in this case about 1 second, which is not acceptable for real-time sharing. And in the last case, VERS protocol is used. You can see that the delays are, in most of cases, very low, but on the end, all data are recent, so there is not inconsistency between client and server. So that's all.
Okay. You want to say something? Other questions?
The question was when it will be re-implemented to the Blender. I don't know. I have to finish my PhD studies, and then I will have time to this funny thing.
Now he has a question.
I apologize that my presentation was a little bit boring and technical, but it's network protocol. Yeah, Eskil.
So first of all, thanks for your talk. And I have about 1 million questions. They're really, really deep and technical. But the one that I want to ask here in public is, have you considered writing a bridge between old and new? Would that be possible? I mean,
I didn't think about it, but maybe it could be possible. It's similar in many ways. The recent mechanism is it uses many same approach. So I hope it will be possible. You created many cool applications using VERS. So
thank you.
I think it could be possible at least to rewrite it using new VERS protocol. Or it's open source, so you can reuse many of my new things to your VERS protocol. So it's my new VERS protocol is a result of academic research, so it's not something that is necessary to be useful right now, but I think it has some valuable results. Yeah.
Okay, thank you. Then we move to the next. We're still behind schedule. 1 minute break, and then we have the University of Visualization. I have the schedule. Oh, Munich, yeah.
Can I get a glass of water? Can I get a glass of water?